Hi, my name is Daniel, and I'll be talking about Redis today. There's a bunch of content in these slides that I'm not going to go through in full detail because it would be too long and too detailed. But if you download the deck, at the end of the presentation, you're going to have the URL. There's a lot of detail in there if you're interested. So I like to give this talk because I think Redis is extremely awesome. And I think it's very underutilized. It's very misunderstood. And from my experience, I think the reason for that is that asking the question, what is Redis, usually gives you some version of this answer. Basically, Redis is Memcached, but better. It's a key value store, right? And then the problem is it's not actually just that. And then you ask, you go like, okay, just better how, right? And it's like, well, you get persistence and something about data structures. And so you go like, okay, and you just use it as a cache. And then you try to learn more, and you hit this, right? Which is the commands page, which is the obvious entry point to the documentation. And it's not very clear where you're supposed to start. And it looks like assembly opcodes, and it's scary. So you go like, no. And you just use it as a cache. And it's a cache with hot reloading. So if you have to restart it, you don't start cold, which is great. But that is about 0% of what it can do for you. And that makes me very, very sad. So I'm trying to get to give you a different approach. So I think the problem with this, why Redis is so misunderstood, is the Redis is a very unique beast. So we all know what SQL databases are for. We all know how they can help us. We all know what NoSQL databases are for and how they can help us. But basically, it's not very clear what a data structure server is. So why do you want that? And so to me, the difference between Redis and other databases is like most databases are a great hammer, right? And we all know hammers. They solve all the problems for you. Everything looks like a nail when you have a good one. And you can just use them. And to me, Redis is more like wood carving tools. It's basically, in wood carving, you have all these super sharp, very specific tools with different shapes for different particular specific problems. And that's, to me, what Redis is like. So Redis gives you super, super focused solutions to very specific problems. And you can take all these different, very, very narrow, very specific solutions and combine them to solve more interesting scenarios. So the way it does that is, again, with the data structures. And I'm going to be talking in more detail about them. But one of the weird things I found when starting is the commands. Basically, Redis is a text interface, sort of like Memcached. And you have hundreds of commands to interact with this data structure. So you're going to have, just for an example, you're going to have sets. And then you're going to have a bunch of commands that let you do things with those sets. And so to try to explain it a bit, I think the best way of doing that is giving you some use cases. Basically, some experiences from past lives where I found Redis super useful to solve very specific problems. And that's very arbitrary, because it's just what I've encountered. But I think it gives you a good idea of what you can use it for. First, however, I need to give you a bit of background. So I want to talk about a few features that Redis has. Number one, Redis has persistence. It is a database. It's not a cache. If you put data in there, it will stay in there. It's not ACID. You don't want transactional stuff there. In a catastrophe, you can lose 1 second of data. So critical stuff shouldn't go there. But everything else, if you put it there, it's going to be there when you go back. It has PubSub, which is a bit of a narrow scenario. But if you have a problem related to this, it's really handy because it's just cheap. You just put it there and it works. It gives you blocking reads, very similar to PubSub. You can ask it to give you a value from a list, for example. And if there's nothing there, you just block until something shows up, which is fantastic for producer-consumer scenarios. It gives you atomic changes. You can send a bunch of commands all at once, and they all happen atomically, which helps you a lot with concurrency. And I'm going to talk about a lot more about this later. It's the easiest message queue ever. Again, as I mentioned before, if you just have producers pushing things and consumers just waiting for something to show up and then just looping over that, it's super easy to make one. And I need a proper clicker at some point in my life. And yeah, the actual interesting bit is it gives you data structures. which is where the real power comes from. Is the microphone helping? Because I feel like I'm doing this. Should I keep using it? Yes. OK, cool. So let's talk about a few data structures. First of all, you get strings. You set strings, you get them back. This you can set a timeout, like expiration for them. This one slide here, this is all of Memcached, right? Everything else is the things that make Redis more interesting. You get hashes. You've probably found this. You can have a hash with a key with a bunch of subfields, so you can get them or set them all at once, or just independently. You can increment them, for example, independently. There's a bunch of interesting uses for this. And this is where it starts to get interesting. You get lists that are basically doubly linked lists that you can push and pop from both sides. So you can push from one side, pop from the other, and you get a queue, or you can push from one side and pop from that side, and you get a stack. And you get that weird instruction, rpopl push, that you see at the bottom, which basically atomically pops from one list and pushes into another. So that value is not lost. You know it's somewhere else. And one interesting thing it lets you do is pop and push from the same list, so you get like a circular tape. You get sets, which are like lists, but there are unique values. And one of the interesting philosophies of Redis is when you do something twice, if you will, the second time is a no-op. It's not an error. So lots of times you're going to have a set that has a list of other keys, for example. And you just constantly, when you add to the other keys, you constantly add to the set, independently of whether it's there or not. It's cheaper than checking. You just add it again. And yeah, you get a few instructions that are interesting, including set arithmetic, which if you ever use, please let me know, because I want to find a good case for that. And this is, to me, my favorite thing of all time, sorted sets. So sorted set is a set with unique strings, but each one has a float value associated with it, a float score. And the way it's stored internally is designed so that it's very quick to query by that score. And like sets, adding twice just updates the score. So you can just keep adding to it and adding to it to update the scores. And so this lets you do things like give me all the values that are within this range of scores, or given a value, give me which position it is. This is, among other things, a leaderboard in a box, right? It's already done for you pretty much. And this is ridiculously fast. It's ridiculously efficient the way it does that. And it enables a lot of functionality that you would struggle to get as efficiently with another database. So going back to a couple of features. I mentioned this briefly, pipelining. Because Redis is ridiculously fast, generally sending one command or sending 1,000 commands takes exactly the same amount of time, which is the round trip time, right? And so it's very practical to just bundle up a bunch of commands all at once and send them together. And it's going to basically save you round trips. So one example I have is if you have counters. Let's say you have song downloads, right? And you're counting somewhere how many downloads you got per song, per country, per genre. You can just increase all three of them in one round trip. Just send 3 increase instructions, and that's it. You can't do that if you need to read data, though. Obviously, if you need to read it to issue another command, you're going to have to wait for the round trip. But there's ways around that. And the other one that is to me very important is atomicity. Redis is single-threaded. Lots of people consider this a disadvantage because Memcached is technically faster, being multi-threaded. But Redis is so fast you will very, very rarely max out on CPU. So this is not a problem. And what this gives you is when you send a transaction, you send a bunch of commands that need to execute together, you know they execute all at once, and basically everything is internally consistent. It makes it really, really easy to reason about high concurrency scenarios and be very confident that what you're doing is going to be correct at all times. It's much easier than database logs or other things where you actually have multiple threads interacting. So finally, let's talk about some use cases. This is, as I said, an arbitrary list of some cases I found in my life before, where it can help you improve mostly performance, but also sometimes it just makes things easier. So one of these is IP2 location. We all had to do this, right? You get an IP for a user, you need to know what country they're from. And I found basically 3 approaches to this. You can call an external service, ship the problem to somebody else, and that takes about 100 milliseconds to go and come back. You can take a table of basically IP ranges, so with IP from IP2, and then you query that, and that takes about 20 milliseconds. It's a 500,000 record table. And normally you do this, or you do one of these 2, and you cache the result in Redis. Or you can just put that table in a sorted set, right? This is one of the interesting cases where this helps. You have the IP2, so the end of the range of IPs in the score of the sorted set, and the country in the value. And you just go, give me the first value that is lower than this, and higher than this. So you take your IP and say, give me the first one that's higher than this with that instruction, and that basically gives you the result. That takes about 1 millisecond, so you don't need to cache it. You might just as well have Redis do it for you. Another interesting one, how many people here have found Psychic useful? Great. Maybe this is not going to be so relevant, but basically Psychic is a background job processor. So you have your web app or whatever, just put jobs in a queue, and then Psychic is processing them in the background. And Psychic uses pretty much all of the data structures of Redis. So you have the list of things to do are actual lists, and you push, and you do the blocking reads, so if there's nothing, you don't have to keep polling. But also, one thing that Psychic has is scheduled jobs. You can say, run this job in the future. And another thing you have is, if a job fails, it reschedules it to run in the future also, and with an exponential backup. So it's going to wait longer and longer and longer for each retry. And both of these are done with a sorted set. So basically, when something fails or you run it in the future, you put the same value you put in the list, which is the job to run, and you give it a score with the timestamp of when it should run. And what it does is every now and then it goes like, oh, is there something with a timestamp less than now? Grabs all of those, moves them to the lists, and then goes on from there. This is another example that I found really, really useful. This was a massive, massive bottleneck I had in a previous company. And it basically, Redis completely solved it for me, which is buffering updates to the database. We had several tables where we need to either update or insert, and we didn't need the data to be immediately there for reads, but it trickled in, right? You get one record at a time. And so it's kind of hard to do multiple inserts all at once, which you can totally do in Postgres, but you're just getting the records one by one. And so one thing you can do is, for inserts, for example, you just take all that information and you put them in lists in Redis, and then you have this background cron job that every minute or every 10 minutes goes like, okay, give me 1,000 records from Redis, shove them into the database all at once. Just give me one. And that saves you a lot of time compared to just sending them one by one to Postgres or to Mongo or whatever. And yeah, this will be the command. Like lrange will give you n records from the list, and then you ltrim to remove those, basically. And a more interesting one is updates. So if you're updating a record, for example, you have, this is the last time I saw this user, that's going to kill you in contention. Basically, everything locks each other out, and it's horrible. And so what you can do is you store in Redis in a hash. Basically, this is the key to the record, and this is the value that I want to set. And you have all the IDs to all the records in a sorted set with the timestamp of when's the last time they changed. And the idea here is the one that changed most frequently is probably going to change again, so you want to do the old ones. And then every 10 minutes, you take the 1,000 IDs that changed the least recently, you remove them from the set, and then you get all of those values from the hash, and then you do some magic in Postgres with temporary tables to do all 1,000 updates all at once. This basically gave me a 10x improvement in my bottleneck, which was user sign up in my site. Just doing this completely shot through the roof how much throughput I could get. If you're updating an increasing number, then you don't even need the hash. You just put the value of that increasing number in the sorted set, and then it's easier. Oh, one thing I forgot to mention. You do all of these also atomically, in case you have multiple consumers doing this, with a Lua script. So Redis has scripting, which you shouldn't use for everything, because it's obviously slower than not scripting. but it's actually quite fast and it works really well. So a simple one, which is kind of weird, which is a round robin, right? You have n resources that you need to distribute things through, and basically every time you need to know which one to use. You have a list with all the servers, for example, or all the whatevers, and you do this magic error purple push from that list to itself. So that will give you the value at the top of the list and then put it back on the list. So just with that, you get the round robin. The reason I'm mentioning this one is because it's a good way of thinking about the next one. This is another huge one. I'm not sure if you guys have ever had to send a few millions of SMSs, but if you do, the USA gets very picky. You have to own your own phone lines, which Nextmo or Twilio will sell you. You can only send 500 messages per day per phone line. If you send more than that, you will be blocked, and you just never can send from that phone line again. You can send more than one message per second, and this one is really horrible. And if you do, it's not going to get throttled, it's going to get rejected. And surprisingly, Twilio doesn't magically solve this for you, even though it sounds like it should. So you need to do it yourself. And so, as we said before, right, we just have a list of phone numbers, and then we do error purple push, and then we round robin around that. And that would be great, but this is not rate limiting at 1 per second, and it's not, you're never going to run out of messages in a line. And so again, we use sorted sets, my favorite thing. So you take a sorted set, you store all the phone lines there, and you put on the score when's the last time that you sent a message with them, with milliseconds. You also keep a hash that has in each field the phone line number, and then the value of that hash is a counter of how many messages you've sent today, and the date of today is in the key of the hash, so you get a new hash every day, obviously. And you also have a set on the outside, which is depleted phone lines that send more than 500 messages, which will hopefully be empty, but it can get full. And so to grab a phone line, when you need to send a message, you ask the sorted set for a value within a range of scores, where basically the score, which is the last time we sent something, is at most 1 second ago. So if there's some line that we haven't used in the last second, you're just going to get that one, and the oldest one. But if all of your lines, let's say you have 10 phone lines, if all of your lines have sent a message in the last second, then this is not going to give you anything. You fail your job, and you're going to retry through the magic of whatever queue system you're going to be using. And then you grab that, and you re-add it to the pool again, updating the timestamp to now, so it's blocked for another second. So this gives you the rate limiting automatically. And the other thing you do is, after you've sent the message, you increase the hash value, and that increasing it will give you back the new number. And if that number is more than your limit, then you just remove it from the list of available phone lines and put it in the depleted phone lines list. You have a full second to do that before somebody else grabs it, so it's pretty safe. And so why all this thing? And well, if you're going to have a Super Bowl ad promoting your app, and you're going to have a few millions of signups in about half an hour, this will let you have 10,000 phone lines, 1,000 Sidekick or whatever you're using for workers, sending SMS like madmen, and you're guaranteed to comply with those rules, and it's going to work great. If you try to do this in Postgres, especially the rate limiting, contention will basically kill you. It's not going to get anywhere near the throughput you get with this. So yeah, that's another example where the efficiency of the atomicity that Redis gives you is super effective. And finally, this is my favorite example. Let's say you're doing a messaging app, kind of like WhatsApp, where we find who your friends are basically based on your phone book, right? So when you sign up, we take your phone book, we upload it to the server, hashed, so we don't know what those numbers are, but when some of your friends sign up, we can find you, right? And what we're trying to do is, this guy signs up, we know these two are his friends, this other guy signs up, these two are his friends. When this guy on the right signs up, we want to notify A and B and say like, hey, Daniel just joined your app. Just message him so he feels welcome, and then he feels welcome, and everything is more viral, and billions of dollars of valuation, or whatever. And now, in my experience, Redis solves this problem perfectly, almost, and better than anything else I've seen. If you have any ideas how to do this with any more standard database, I'd love to hear that. And you have two problems to solve here, right? Reading and writing. So every time somebody signs up, we need to store 1,000 records to the database, and we need to do that really fast because Super Bowl ad, and we're getting millions of signups. And you also need to be able to find who to notify when somebody signs up. This doesn't have to be super fast, but it needs to just be somewhat resilient to contention. If everything logs, then you're screwed. And so the obvious way is you just take a huge table and you say, for this user, these are all the people in that in his phone book. And when you index the big column, and then when somebody signs up, you just find all the users that had that guy in their phone book, and then you notify them. Writing this is okay-ish. You can send the 1,000 records all at once to Postgres. By the way, I'm saying 1,000 because that's about an average phone book. You can send all those at once with one round trip, which is great. Concurrency-wise, writing to that, that's okay-ish. Updating the mega index once you have tens of millions of users gets a bit slow. And reading, Postgres is not very happy with this, to be honest. It works, but yeah. So we need a better solution. Another one is we can take a document store, right? And we invert that table. Instead of saying this person knows these 1,000 people, we say these 1,000 people as individual keys are known by this person, right? You turn it around. And so, for example, 2 people know the same guy, so you have that list of who are his friends. And so when this guy signs up, you immediately know with a really, really fast get who to notify. So reads for this are great, but writing to this is a nightmare. Basically, you can do all the writes with one round trip, as far as I know. You need to just update each record one by one. And then if you have, you can say add someone to the list that is friend of. You need to read that and rewrite it. So it's not great for concurrency. You're going to lose data. And so Redis comes to the rescue, which basically gives you the best of both worlds. You do the same idea, that inverted phone book index. You write 1,000 of them. So like each one of these 2 pipeline ads are a user signing up. Right? So each one of these is just one round trip. It will take about a millisecond because it's ridiculously fast. And then when you read it, you already have that set, that key that already has A and B to give you back. And so you can write really fast. You can read really fast, which is awesome. Almost. Because Redis is basically an in-memory data store. And so the biggest instance in AWS is, 140 gigs of RAM. That's about as far as you can go. There are solutions to this. There's a proprietary extension that lets you use hard drive in addition to memory, which for this is great because the performance would work. But that's kind of the limitation. That's why I'm still trying to find some other solution. But also, this is really, really easy to shard if you need to have multiple Redis servers. The main problem is, again, RAM is more expensive than disk, right? So, yeah. So, why do we care? Like, can't I just use Postgres and replace Postgres with whatever you prefer, right? And yeah, like, relational databases are awesome. Postgres 9.5 has that skip locked modifier, which is amazing because you can, when you're reading a record, instead of waiting on the locked one, you can just say skip that one and just give me the next one. That helps a lot with the phone line rotator scenario, for example. But Redis is basically more efficient by just having these really, really narrow data structures. It can do these very specific things for you, which are, again, less generic, but when you have a particular problem that it can solve, it will solve it really well. And yeah, sorted sets are way faster than indexes. Popping things from databases is really awkward. Like, again, you get that long lock contention. It's great to have a buffer. We can just temporarily add stuff until it gets to the database. And concurrency is really, really easy with Redis. Like, it's much easier to think about. Now, truth is, at low scale, this doesn't matter. Just use a relational database. At Facebook scale, you're screwed anyway. You're going to have to just do everything yourself. In the middle, Redis can help you a lot. Like, this talk is all from my experience with one company through load tests and then through real load, improving the throughput of the server, and most of it was just going like, oh, this is a bottleneck, Redis can help with that. This is another bottleneck, Redis can help with that, right? So to me, one very important thing was like anything Redis can do, even if it's not more efficient at it, which it generally is, but even if it isn't, anything Redis can do for you is something the database doesn't have to do for you, and so you free up the database to do other more important shit. And now I've I've bashed this page before, the commands page, but actually it's really good. So once you understand what data structures Redis gives you and what they're for and how they can help you, you basically go to this page and just filter by that data structure, and you get all the commands. And generally, there's a command to do exactly what you want. It's like, oh, I want to insert the thing here, but not. There's one command for that, generally. So definitely use the documentation, which is amazing. And that's it for me. This is, you can download the slides there. After this slide, there's a bunch of others with more details that are more just too narrow to give in a talk. Pretty much all the use cases that I've talked about, I've either put in a gem or I'm in the process of putting them in a gem or want to. So if you have any of these problems, definitely talk to me. And anything else, like if you think I can help, I love brainstorming how to use Redis to improve anything. So just send me an email. And I work for Appear here. It's a great company. We're a startup. We're growing fast, and we're hiring. So if any of you is an experienced Ruby developer, we definitely want you. Thank you. That's it. So hopefully some of that made any sense. Do you have any questions? How does Redis stands up to DOS attacks? Better than most other things. And now, the thing is, you're not going to have Redis publicly available. That is actually very, very discouraged. You technically can, but you really shouldn't. So you don't want things from the outside connecting directly to it. It's always going to be behind your firewall. And it's generally going to be faster than anything else. So your web server, your database server, anything else that's in front of Redis will be slower than Redis. So should do very well. Like if you look for benchmarks of how many transactions it can give you per second, it's just ridiculous. Yes?
What resiliency options have you got? If you've got clustering, what resiliency options do you have? You mentioned persistence.
Yes. Redis, sorry, the question was what resiliency options in terms of clustering do you have? Redis 3.0 has clustering options. I'm not a big expert on those because I changed companies and stopped having performance problems before Redis 3.0 came out. I know that clustering has both master-slave replication. That's actually before 3.0. It also has this magic, how do you call the consistent hashing sharding. So you basically get pretty much magic sharding. I'm not sure if that answers the question or not, but like it does have clustering options. But I'm not a super expert on them.
Do you have any experience with Redis Sentinels and how you use it?
Very little. Because most of my experience with Redis was somebody else hosting it, including the clustering with the failover for the master and slave. But by the way, I'm not in any way endorsed by them, but Redis Labs is awesome. I really like them. Like if you need a hosted Redis solution, I'm quite happy with them, using them in the past. Yes? What were the biggest problems I faced using Redis? It's very narrow in the sense of, again, you have these data structures and this is what it does, and sometimes you want it, and it doesn't do that for you, right? And you have to kind of hack your way around it and go like, oh, well, maybe if I combine this data structure with this other one and you put a bit of Lua glue in the middle, you end up getting around it. But it's not as straightforward as a normal database because it's less generic. But that's kind of by design. Other than that, I haven't really had any. I've never had performance problems. I've never had data loss problems. And it's possibly one of the easiest processes I've seen to run in production. You just run it and it runs and it just works. It's ridiculously simple, which is part of the appeal.
Probably a lot of us are using JSON, and you mentioned very early on that strings are where you want to put your JSON. But if you have like JSON with JSON inside of it, like a Java object with an object inside of it, there's no support for that in Redis. I mean, you can have a top-level hash, but not like a hash within a hash.
Correct. Yeah, hashes are one level only. If you have a deep object hierarchy, you'll probably just serialize it to JSON and then put it in Redis. Because the question was like, what happens when you have a multi-level hash? What are you putting in those hashes?
I suppose if you use like Mongo, then you can query on that lower level hash, right?
Yeah, that's not what Redis is for. In fact, for you're not going to query the values of a hash. You're just going to say, give me this field or these fields of the hash with this key. But that's it. You're not going to map reduce through the values and find the ones. That's definitely not what it's for. If you want to do that, you should store it the other way around, right? And then just search through those. Yes?
So, yeah, you mentioned that Redis is a persistent storage.
Yes.
At the same time, it's a memory-based key-value
Yes.
storage. How
Yes.
can it be memory-based and persistent?
Right. So it will only let you store in it as much as will fit in memory. So if you have 16 gigs of RAM, you get 16 gigs of database. That's it, right? And everything you do, you write it, it writes to memory, and every read you do, it reads from memory. However, every modification you make to the database, it also writes to this write-ahead log. So basically, it's just dumping to disk every write. And this is why you lose 1 second of data. That's actually configurable. You can set it to write to disk on every write, but you're going to take a big performance hit. And then it's completely bulletproof. If you, in the normal setting, it basically flushes to disk every second. And so you do have the persistence, but all the reads are directly from memory, which is why it's so fast. But basically, on a restart, it will just go through that log and redo everything you've done. And it has snapshots every now and then, so it's not taking forever. But yeah.
Do you use a specific Ruby gem?
Do I use a specific Ruby gem? There's two main ones. There's Redis and then High Redis. There's High Redis. They're exactly identical, but High Redis is faster. And Ruby gems, because Redis has this thing where okay, you have these hundreds of commands that they do these very narrow specific things and you want to use this particular one. The way all Redis clients work is you have this object, which is your connection to Redis, and then you have one method in that object for each command. The name of the method is the same as the name of the command, and the parameters are the same. So you literally be calling sadd, zadd, whatever. So which client you use doesn't really matter. Because it's a very shallow, very transparent interface. It basically handles the bytes in and out the cable for you, but that's about it. Well, the Ruby one will turn hashes into actual hashes and lists into arrays. But again, that's pretty much all it does. So both clients are fine. Yes? Say that again, please. Right, how do you monitor Redis and Amazon without using CloudWatch? I'm not a big fan of Redis and Amazon. It's basically the product is called Elastic Cache, and they're treating it like that. They're treating it like a cache. You don't have a good persistence story. You have clustering. You can just replicate among many servers. And in theory, that covers you against disasters, but you can't see it with your own eyes, because if you restart the server, it will actually flush your database. So you need to actually kill a server, which you can't. And so I don't believe it, that it works. And again, if for some reason something happens, you can very easily lose all of your data. So I'm not a big fan of Elastic Cache. It's very easy to just run a server, like a Redis server, on your own server. Just have an EC2 instance of the memory you want. Let's just put it there. I'm not a huge expert on AWS though, so I know nothing about CloudWatch. Sorry.
I've used Redis with Spring, just a key value cache. Looking at the LUA scripts and stuff, how do you actually call it? Because from Java, it's running on a web app. How do you call these scripts?
So a Lua script, there's two ways. One is, sorry, the question is how do you call Lua scripts from Java? One is the command for running a Lua script is eval, and you basically do eval and you send the string of the script. If you're worried about the bandwidth, you can actually store that script and it will give you back a hash, like a just long random number. And then you should say, call this magic random number. But you wouldn't do that normally because deployment and changing of that is a nightmare. So you just basically send a string everywhere, every time. Lua scripts tend to be tiny, so it's about a K. So you would have a literal string in your code with the Lua string in it, which I know doesn't sound really clean for Java standards, but I think that's how you do it.
Or would you keep it on a separate
So would I keep Redis on the same server as the application? It depends on your setup. I mean, I would keep Redis in its separate thing for the same reason you keep the database on its separate thing, so that, for example, all of the web workers can hit the same instance. But you could totally have one of the instance running Redis. No, you're gonna be doing TCP/IP calls through localhost. But that's insane. Like if you run it in localhost, all the responses come in microseconds, like low numbers of microseconds. So the TCP/IP doesn't seem to add a lot of overhead. So how do you decide which format you store the data in? It depends on, so I know all of my answers are coming back with, it depends. But it does. Like, it depends what kind of problem you're trying to solve. If you're using it as a cache, you're just going to serialize it as JSON and then put them in. If you're trying to do something interesting with this particular field of this object, right? You may have the object in a hash or in a JSON string, and then have this particular field linked to that ID in a sorted set so you can do interesting things with it. It really depends on what you're trying to use Redis for. Like what data structures are you using and why. I'm not sure if that makes sense, because again, it depends on the scenario. But if you want, you can grab me afterwards and we can talk about what the problem would be and solve it. I think I'm being kicked out. But thank you very much, and hope some of that made sense. Thank you.